Okay, in this video we're going to be looking at week 2 pre-req topics. Our first topic is order of operations with integers. Okay, so for order of operations we are going to use PEMDAS. Please excuse my dear Aunt Sally. You may be familiar with this. This is parentheses. So anything in any operations that can be done inside of parentheses, those come first. And then exponents come second. Multiply, divide, but you move left to right. And then add and subtract, and you also move left to right in the problem. Okay, so keep in mind that when you have parentheses, that's only applicable if you have a parentheses that has an operation inside it. In other words, something like this. If you had a parentheses that said 3 plus 2, and then you had like plus 1 after that, well, since there's an operation inside this parentheses, you want to do that first. If you look at these examples, however, notice that there's no operations inside the parentheses. So on these examples, we're not going to have any parentheses and also no exponents. So we're going to be looking at multiplying, dividing, and adding, subtracting. And you have to move from left to the right in those problems. Okay, so let's take a look at the first. So we've got two operations here. We've got 3 minus a negative 3 times 54. Okay, so the first thing we want to do is take care of the negative 3 times 54. It's the only multiplication in the problems, and you need to do multiplication before subtraction. Okay, so we multiply negative 3 times 54. Okay, 3 times 54 is going to be 162, and since it's negative, we'll make that a negative 162. Okay, so there we go. And then I'll keep that in parentheses because we have this negative sign right here and the 3 that I have to drop down. So I drop these two things down. Now I've taken care of this operation. I have negative 162. So now it's 3 minus negative 162. So this negative can be distributed to this negative 162, and it's like multiplying two negative things together. So if you multiply two negative things together, you get a positive. So this becomes 3 plus 162, and if you add those together, you get 165. Okay, let's look at the next one. So we've got subtraction and division. So we look up here, and division comes before subtraction. So we need to do that division problem first. Okay, so we'll take care of this first. Notice that that's a negative divided by negative, so that's going to end up being positive, and 30 divided by 6 is 5. So it's positive 5. And then we'll drop down the negative 6, and then drop down the negative. So you get negative 6 minus 5. So we're adding together now or combining together two negative numbers. I know this says subtraction, but you can write this as negative 6 plus negative 5. So you can think of this way as adding two negatives together, and you keep the sign and add them together. So that's negative 11 is your answer there. Okay. Let's look at this one. We have a subtraction and a multiplication. So we'll do the multiplication first, right here. Okay. So we have a positive, and we're going to keep this negative sign in the problem. Okay. So that'll be dropped down. So I'm going to treat this 5 like it's positive 5 times negative 8. Okay. So positive 5 times negative 8 is a negative 40 because a positive times a negative is a negative. So we'll put that in parentheses. Then you can distribute this negative here, just like we did over here, and make what's inside there positive. So it'll be 5 plus 40, which is 45. Okay, let's look at this one. We have 3 operations this time. So we have, no, actually it's still just 2 operations. So this is a division and this is a subtraction. So we'll do the division first. I'm going to keep the negative here with the problem because it's inside this parentheses. So negative 16 divided by positive 4 is a negative 4. And then I'm going to drop down everything else. Here's my negative 12 and my minus. I'll distribute the negative here and make that a positive. So it'll be negative 12 plus 4. And when you have a negative and a positive and you add them together, you keep the sign of the bigger number. That's the 12. So we know our sign is going to be negative, and then you just subtract the smaller number from the bigger number. So 12 minus 4 is 8, so our answer is negative 8. Okay. On this one, we're going to do the multiplication first before the subtraction. So that's a negative times a negative, which is a positive, and 9 times 6 is 54. So drop down these two terms, and then you get 54 positive, but then you're subtracting. So 6 minus 54. Remember, you keep the sign of the bigger number. The bigger number is negative, and then you subtract the smaller one from the bigger one, so you get negative 48 as your answer. Okay, and then the last problem here for this topic, we will do this first because it's multiplication. We'll save the subtraction for later, so I can go ahead and drop down that negative, the parentheses, negative 6, all this stuff. I'm just taking care of this. So negative 5 times 3 is a negative 15. Okay, so we have a negative 15 minus a negative 6, so I need to take care of this right here, make that a positive, so it'll be negative 15 plus 6. They're opposite signs, so here's the bigger number, so our answer has to be negative, and then 15 minus 6 is 9, so our answer is negative 9. Okay, next topic, we're going to be evaluating a quadratic expression with integers. So what we're going to be doing is putting in these numbers in place of the variables that we see. Okay, so in our first problem we have a 2. So I'm going to put a parentheses everywhere I see an x first. Minus 5 times parentheses plus 8. Okay, so that's where the x's were at. I'm going to replace those x's with the number that I was given, which is 2. Okay, and then we need to remember our operations. Remember, exponents come first, unless there's something to do in the parentheses, which there's not. So we need to take care of this exponent first. That'll be a 4. There's no more exponents. So now I can do multiplication, division next. Here's a multiplication. So negative 5 times 2 is a negative 10. And then I'll just drop this one down to the next step. Okay, so this became a 4. This became negative 10. This I drop down. Okay, I can do the 8 and 4 together to make 12. And then I can do the minus 10. 12 minus 10 is 2. Okay, so I just did this in a slightly different order. I did these two, combine those because they were both positive, and then I took care of the negative. Makes it a little easier. Okay, here, everywhere I see a b, I'm going to replace it with a parentheses. And I'm going to put in that parentheses a 4. Okay, and we'll do the same thing we just did. We'll take care of this first. 4 squared, that is the same thing as 4 times 4. That's 16. And then we can do this multiplication as well, which is 6 times 4 is 24. And then we can drop the 8. So we've got all addition here. Okay, so we can do that. So if we combine the 16 and the 24, that gives you 40. And then add the 8, you get 48. Okay, one last time, put parentheses everywhere I see variable, which is an m this time. And inside that parentheses, I'm going to put 5s. Okay, so I'll take care of this 5, that is 25. Take care of these two, and that is negative 25. Negative times positive, and then plus 3. Notice that these two cancel each other out, right? 25 minus itself, obviously, that's gone. So our answer is what's left, which is a 3. Our third topic, the introduction to the power of a power rule of exponents. Okay, so when you multiply, when multiplying the powers, you are going to add them. Okay, so we add the powers when you're multiplying the bases. Okay, so when you're raising a power to a power, you're going to multiply those exponents. Okay, so if it's like this, you have the same base and you're multiplying, and they each have their own exponent. You just add those exponents up. This, if you got a base to an exponent to another exponent, you multiply them. Okay, so that's what we're going to be doing in these problems. So we've got x to the 6 to the 3, so that's x to the 6 times 3. And 6 times 3 is 18, so you get x to the 18. Oops. On this one, you get v to the 2 to the 5. That's v to the 2 times 5, which is v to the 10. On this one, you get z to the 6 times 2, which is z to the 12. This one, you get u to the 4 times 5, which is u to the 20. And on this one, you get w to the 3 times 3, which is w to the 9. For our next topic, we're going to be simplifying a sum or difference of two univariate polynomials. Okay, so univariate means there's only one variable. So like in this, there's only a v as your variables. In this one, well, it's also a v. In this one is only an x. This one, there's only a w. That's what it means when they say univariate. And they're polynomials because they have more than one term in them. So this has three terms and this has two terms. So this would be a trinomial and this would be a binomial. But they're both polynomials because they have more than one term. Okay, so all we're going to do here, since this one's adding, we're just going to drop the parentheses and then write it all out and then combine like terms. Okay, so there's no like terms for the 4v squared because there's no other v squared term. So I'll write it down. On the v term, there are multiples. There's negative 5v and negative 3v. So if I add those up, they're both negative, so add them up, keep the sign. That's negative 8v. And then last, you've got the numbers, negative 7 and 2. Those are different signs, so you keep the sign of the bigger number, which is this one, and then you subtract the bigger one minus the smaller one. 7 minus 2 is 5. So this is your answer. Okay, on this one, we do have a negative, so before we just drop the parentheses, we do want to distribute this negative sign into that parentheses, and then we will drop the parentheses. So 2v minus 1 gets dropped, and then the negative gets distributed to this to make it negative, so minus 3v squared. The negative goes here, which is already negative, so it becomes positive 5v. And then the negative goes to the negative 1, and that makes it a positive 1. Okay? So you look at like terms. We have a v squared term. There's no other one, so I'll write it down first. And you always start with your biggest exponents and then get smaller as you go. Okay, so that's why I started with the v squared here and here. Then you have this 2v term and this 5v term that will combine to get 7v. We're adding. And then you have negative 1 and positive 1, which cancel each other out. So there's no number left, and it's just those two things. Okay. Let's look at the next one. So let's distribute again, and then we'll drop the parentheses. So you have negative 7x squared plus 2x minus 1. That's this one. And then we distribute, so we change all the signs. They're all positive, so now they're going to all negative. Negative 4x squared minus 3x minus 6. Change all the signs. All right, so combine like terms. Start with the x squared terms. We have negative 7 of them and negative 4 of them. Add and keep the sign. So negative 11 of those x squared terms. So negative 11x squared. Now for the x terms, we have 2 x terms here and negative 3x terms here. So 2 minus 3 is negative 1. So we could write negative 1x, or we could just write negative x. The 1 is implied if there's no number there. And then lastly, we've got negative 1 and negative 6. Add and keep the sign. Negative 7. Okay. On this one, there's nothing to distribute because it's already positive. So you can either do what we did here and just drop the parentheses and then combine like terms, or you could just pretend the parentheses aren't there. Since we've already done a few of these, that's what I'm going to do. So let's just go ahead and combine like terms. You got 5w squared and a w squared. Add them up. 6w squared. You've got 4w and 2w. Add them up. 6w. Then you've got 6 and 7. Add them up. 13. Okay, for the next topic, we've got square roots with perfect squares with signs. So we are going to, since this is the beginning of the course, we're not going to talk about how to tackle negative square roots when the negative on the inside. Okay, we're just going to say for now that these are not real numbers. We'll talk about imaginary numbers later in the course. But for now, if you see a negative down here inside the square root, then those are automatically going to be not a real number. Okay, but if it's outside of the square root, all that does is change your answer to negative instead of positive. So that's it. Okay, so if you, like, all these have nice square roots. Okay, so let me write out the nice square roots. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. 11 squared is 121, and 12 squared is 144. Okay, so those are all your square numbers up to 12 squared. So all those numbers should be, all these answers should have should be listed here. Okay, so if you're looking for 144, that was the last one. That's 12 squared. So we know the square root of 144 is 12 because 12 times 12 is 144. Then we just drop that negative because it's in front of the square root. So our answer is negative 12. This one has a negative on the inside. So since we don't know how to deal with imaginary numbers or complex numbers yet, we're just going to say not a real number and then move on. Okay. Square root of 1, I guess I should have wrote that on the list because 1 times 1 is 1. So the square root of 1 is 1. So we know the answer without the negative is just 1. But then the negative just gets carried down. It's out front, so that's fine. It just makes our answer negative. Okay. This one has a negative on the outside and the inside, and you may be tempted to say, oh, well, just distribute that and it'll be fine. You can't do that. You cannot do that with square roots. Okay. You just look at it and say, oh, there's a negative on the inside. Not a real number. That's it. So anytime at this point in the course that you see a negative inside the square root, you stop and say not a real number. Okay. This one has a negative on the outside, so all that's going to do is make our answer negative. And then what times what gives me 25? 5 times 5. So my answer here is negative 5. Okay, our sixth topic here, we're going to use the multiplicative property of equality with signed fractions. We're going to solve for the variable. Okay, so when we're solving for the variable, we need to get everything that's with the variable away from it. Okay, so what can I multiply on this side so that this negative 2 gets away from that v? Well, we'll do the opposite of a negative 2. We will divide by 2, which you could also look at as 1/2, multiplying by 1/2, okay, because the 2's on bottom, which will cancel out with that. But what about the negative sign? Well, let's leave that for now. We won't tackle that yet in this problem. But if we multiply by 1/2, we have to multiply the other side by 1/2 as well. Okay, and that, you know what, that looks like I'm saying it's subtraction. It's not, so let's put it over here. Okay, so over here we could put a 2 over 1. You remember when you have a fraction times a fraction, you multiply straight across. Okay, so it'll end up being negative 2 on top and a 2 on bottom, and that will reduce to 1, or you could just cancel these out. So it cancels out and leaves negative v. And on the other side, you do top, top, bottom, bottom as well. That becomes negative 4 over 18. Now that can be reduced. Okay, if you divide the top and bottom by 2, that becomes negative 2 over 9. Okay, so negative 2 over 9 equals negative v. And then you want the negative sign to not be there. So you need to multiply or divide by a negative 1. It doesn't matter which you choose. But in essence, when you do this, you're changing all the signs in the problem. Okay, so this changes the v to a positive v. This also changes this negative number over here to a positive number. So you get 2 over 9. Okay. And if you ever wonder, did I get the right answer? You can always plug it back into the original and see if it works. Okay. All right, on this one, we have, with the v, we have something that's multiplying and dividing it. Okay, so when you have that, we can multiply what we call the reciprocal. Okay, so let me write this a little bigger, give myself a little room here. So here's the 7b over 9 equals 42. Okay, so I'm going to multiply by the reciprocal of this, which is just, we'll do the negative to get rid of it, negative 9 over 7. So what that essentially does is reduce that and reduce the 7's, and the negative all goes away. So when you multiply by the reciprocal, it makes the numbers disappear, and when you multiply a negative by negative, it makes it positive. So all that gives you just the v on this side, which is great. We've already solved it, but we do have to do it to the other side. Negative v, or negative 9 over 7. You could put the 42 over 1. Okay. Now this is going to turn into a big number, but you could reduce if you notice that 7 goes into 42. So divide 7 into itself, and it cancels. It becomes a 1. divide 42 by 7, and it becomes a 6. So you end up getting, I have not quite done yet, when this reduces, you get 6 over 1, that's this one, times negative 9 over 1. So we divided both of these by 7, and this is what we got. Now we can just multiply. We can drop the 1s and multiply. That's going to be negative 54. The 1s go away. 6 times negative 9 is negative 54. Okay. For the next one, I'm going to write it down, give myself a little extra room here. So we have negative 14 over 9 equals negative 7x. Okay, so for this one, we just need to get rid of that negative 7. So I can multiply by negative 1 over 7. Multiply by negative because it'll make the negative go away. Multiply by 1 over 7 because this 7 and this 7 will cancel. Okay, so when we do that, the entire other side is just x. That's all that's left. But we have to do it to the other side as well. So negative 1 over 7. Okay, the negative, again, will cancel. Okay, so you will get 14 over 9 times 1 over 7. And now you might notice that 7 and 14 are both divisible by 7. So I can divide those both by 7, which will give me 2 over 9 times 1 over 1. Okay, and 1 over 1 doesn't really do anything, so we just get rid of it. Our answer is x equals 2 over 9. Okay, let's do that last one. It's negative 6x equals negative 12 over 7. Okay, so we want to get rid of that negative 6, so we'll do kind of like we just did. Negative because we want to get rid of the negative, and then 1 over 6 because it'll make this 6 cancel. So all of it cancels, and you're left with just an x. Negatives cancel, the 6's cancel, but you got to do it to the other side as well. So negative 1 over 6. Okay, notice in the next step that the negatives are going to cancel because it's a negative times a negative, so you end up getting 12 over 7 times 1 over 6. You can divide the 6 by 6 and the 12 by 6. So this becomes x equals 2 over 7 times 1 over 1. The 1 over 1 goes away, so you just get x is equal to 2 over 7. Okay, on this topic, we'll be solving a linear equation with several occurrences of the variables on both sides with multiple distributions. Okay, so we want to solve for u, but we've got u kind of all over the place here. We've got a u here, we've got a u here, we've got a u here. So the first thing I want to do is get rid of the parentheses. So I go ahead and distribute on both of those. So 7 times u is 7u, 7 times 3 is 21. Equals, and then we distribute this, negative 3 times 2u is negative 6u, and then negative 3 times negative 5 is positive 15. And nothing happened to the 9u in this step, so we'll just drop it. Okay. Then we want to get combine the u's on both sides if we have them. Here we have multiple u's, so let's combine those. So you get 7u plus 21, nothing happened to that. We combine these, 9u minus 6u is 3u plus 15. Okay? And now what I'm going to do is move this over here by subtraction. So minus 3u minus 3u. That will give me 4u, 7 minus 3, plus 21 equals 15. Then I will get the number, what's not with the u, 21, and move it over here. So I'll subtract the 21. So that'll be 4u. And then 15 minus 21, remember the sign of the bigger number, so it's negative. And then subtract 21 minus 15 is 6. Okay. And then finally, let's get rid of this 4. It's being multiplied, so let's divide by 4, or multiply by a fourth if you want to do it that way. Okay, so u equals negative 6 over 4, but let's reduce that. Let's divide the top and bottom by 2. So if we divide the top by 2, 6 divided by 2 is 3. The negative, nothing happened to it. It's still there. And then the bottom, 4 divided by 2 is 2. So our answer is u equals negative 3 over 2. All right, let's look at the next one. So we'll distribute again. Nothing happens here. And then distribute there. So negative 3 times negative 6y is positive 18y. Negative 3 times positive 2 is negative 6. Drop down your negative 6y. Equals 2 times y is 2y. 2 times negative 7 is negative 14. And then drop down your minus 4. Okay, so on both sides we're going to combine any like terms that we have. We have these y's over here that need to be combined, and we have these numbers over here that need to be combined. Okay, so 18y minus 6y is 12y. Drop the 6. On the other side, nothing happens to the 2y, but negative 14 and negative 4, they're both negatives, so you add and keep the sign, so it'll be negative 18. Now what I'm going to do is move this 2y over here by subtraction. Okay, so, whoops. That will give me 10y. Drop the 6. Over here, this is gone, so it's left with just a negative 18. And now I'm going to get rid of this negative 6, so that means I need to add a 6. That's the opposite, right? Okay, so this is gone, so you get 10y equals, remember this is a negative and a positive you're combining here, so keep the sign of the bigger number. And then 18 minus 6 is 12. Okay. And then we want to get rid of that 10 that's being multiplied, so we divide by it. So that will cancel out the 10, so you'll be left with a y. This needs to be reduced, just like over here. We need to divide the top and bottom by, it looks like a 2. 2 goes into both. So here's the negative. 12 divided by 2 is 6. 10 divided by 2 is 5. So you get negative 6 over 5. Okay. Last one here. So distribute again. Okay, so 3 times v is 3v. 3 times 4 is 12. Equals negative 7 times 3v is negative 21v. And negative 7 times a negative 3 is positive 21. Bring down the 9v. There's no like terms over here to combine, but there is over here. We've got the negative 21v and the 9v. Okay, so over here I'll just write down what I already have. Over here we have negative 21 and a positive 9. Keep the sign of the bigger number, and then 21 minus 9 is 12. So negative 12v, drop down to 21. Okay. Now I'm going to move this v term over there. I got to do the opposite, so that'll be plus 12v because it's already minus. Okay, so that will give me 15v. Drop down the 12. This cancels. Equals 21. Now I'm going to move this 12 over there. I got to do the opposite, so I will subtract it because it's already adding. So that cancels. You get 15v equals 21 minus 12 is 9. And then finally divide both sides by 15. This one again will need to be reduced. So you've got v, because this cancels, equals, what goes into both of these? Looks like a 3 does. So 9 divided by 3 is 3. 15 divided by 3 is 5. So our answer is v equals 3 over 5. Okay, our next topic will be solving for a variable in terms of other variables using addition or subtraction. Okay, so this is one that's going to have multiple variables. Like in this one we have an m and an n. But besides that, they're not very complicated. These are going to be like one thing that you need to do, and then the problem is done. Okay, so if this says solve for n, right now we are solved almost for n, but we have this little negative 8 or minus 18 that's over here. So all I really need to do is do the opposite of that, add an 18 to both sides. That will cancel out the negative 18 and get n by itself, which means it's solved. And then here we have m plus 18, so we just write that out. And that's our answer. Okay. The next one says solve for b. The only thing that's over here with b is the a. It's adding an a, so I'll subtract the a. So I get B is equal to 5 minus A. And on the last one, it says solve for y. The only thing over here with the y is the minus h, so I'll do the opposite, which is add h. Okay, so that gives me r plus h over here equals y. Okay, for topic number 9, we have solving for a variable in terms of other variables using addition or subtraction. Okay, so this is kind of like what we just did in topic number 8. There's just going to be maybe one extra operation that we have to do. Okay, so it says solve for z. That's this one. That means we need to get rid of these two things. Okay, so we just do the opposite, right? So if you see a positive term, then you subtract it. If you see a negative term, you add it. So it's x minus y. So I'll do minus x and then plus y. That'll make both of these cancel. But I also got to do minus x and plus y over here. So here we go, cancel. So equals z. Z is by itself because these two canceled out. And then I get a minus x plus y on the other side. Okay. Here it says solve for r. That's this term. So I need to get rid of these two. So I just do the opposite of both of those. So subtract an s and then add a 5. Okay, so I need to do that to both sides. Subtract an s and add a 5. Okay, so cancel, cancel. Leaves you r on the other side. That's good. And then we get p minus s plus 5. Okay. And then this one, solve for q. So that's this one. So we need to get rid of this 10. We'll subtract a 10. And we need to get rid of this r, so we'll subtract an r. And we'll do it to the other side as well, minus 10 minus r. Okay, that'll make it cancel here, and we'll be left with a negative q. Okay, and then over here we have p minus 10 minus r. Now, the problem is solve for q, right, not negative q. So all I have to do here is kind of change all the signs. I'll multiply all of it by a negative 1. Okay, which multiplying by negative 1 just changes the signs. So this over here will change to a positive q. And then these signs will all change when I distribute this negative 1 to them. So it'll be negative p, positive 10, positive r. Okay, we're going to solve some more equations for certain variables. Okay, on this one it says solve for a. Okay, a is here, but it's being divided by 5, so we need to get rid of that 5. So since the 5 is being divided, we'll just multiply by 5. And we'll do it to the other side as well, because if we multiply by 5 and it's being divided by 5, those two things cancel, and you're left with an a. And over here you have 5h, so a equals 5h. This one says solve for x. We've got mx, so that's multiplication. So we'll just divide both sides by an m. That'll make the m cancel here and give you an x, and then over here you have 7 over m. And then here, solve for w. Over here we have 4w, so we need to divide by that, do the opposite because it's being multiplied, right? So we'll divide that side as well. It cancels out. So you get a divided by 4 equals w. Okay, we're going to be solving for a variable again, but we're going to this time have some numbers that are on the same side, multiple variables. So let's see what we got what we need to do. So we're solving for b here. That's this term. So I need to get rid of the 2 and I need to get rid of this 3c. The first thing I'll do is get rid of the 3c, okay, because it's not actually touching that b. So I will subtract a 3c from both sides. Okay, so that gives me 2b. This cancels. A minus 3c. Then I need to get rid of the 2 that's touching the b, so it's multiplying. I'll divide then to get rid of it. And I can just divide. You can either divide term by term, so you can do a divided by 2 minus 3c divided by 2, or you can just put a line under all of it and write it like this. So it'll be b equals a minus 3c over 2. Okay, this one says solve for b, so I need to get rid of the 15 and the 9c. Get rid of the thing that's not touching it first, so the 9c, subtract it because it's being added. Okay, so these aren't like, so I can't combine them, so I'll just write them both down. 6 minus 9c equals 15b. Okay. And then I get rid of the 15 by dividing it, since it's being multiplied. Divide the whole other side by 15. Could do term by term if you wanted. So 6 minus 9c over 15 equals b. Now, while this is technically the correct answer, it's not fully reduced. You might see that there's a number that goes into all three of these numbers. Okay, so if you see that, you want to divide by the common number that goes into all three, which is 3, just to reduce it properly. So I'm just going to divide all three of these terms by 3. 6 divided by 3 is 2. This is a negative 9c that I'm dividing by 3, so that'll turn into a negative 3c, 9 divided by 3. And then 15 divided by 3 is 5. So this is the same answer. This one's just fully reduced. Okay. And then this one, solve for n. That's this term. So I need to get rid of the 7 and the 4m. I'll get rid of the 4m first. Okay, so subtract the 4m from both sides. So that cancels, and we're left with 7n equals d minus 4m. And then I want to get rid of this 7 that's touching the n, so I'll divide it since it's multiplying. And we get n is equal to d minus 4m divided by 7. Now we don't have to do the same thing that we did here because there's no number that goes into 7, 4, and what's the number in front of this? 1. So we leave this one alone. This one's done. Okay, so the last topic in the Pre-Req week 2 videos is solve an equation that's written in factored form. So it says if you have a times b equals 0, then either a equals 0 or b equals 0 or both equals 0. Okay, so we're going to assume the first one to find possible answers. We're going to make it to where both of these are equal to 0 and solve for potential solutions. Okay, so this is written in factored form. We have w minus 7 and w plus 9. I'll write them separately and set them both equal to 0. Okay, so on this one, we just need to solve this for w. So it's w minus 7. So I'll add the 7. So that'll give me w is equal to 7. That's one solution. And then over here, I will subtract the 9, do the opposite. So that's w equals negative 9. Okay. Here we have z minus 3 equals 0 and z plus 1 equals 0. Z minus 3, I'll add the 3 to both sides. And the z plus 1, I'll subtract a 1. We're just doing the opposite, right? So cancels, you get z equals 3. And then cancels, you get z equals negative 1. Okay. On this one, we've got, it's a little more complicated because we've got a number in front of the variable here. So we'll set that one equal to 0, and then 5 minus u equals 0. So this one is a little tougher to solve. Okay, so the first thing we need to do is, well, we need to solve for u. So let's get rid of the 7 first, then get rid of the 3. So subtract the 7. That gives us 3u equals negative 7. And then divide the 3. And we get u is equal to negative 7 over 3. If this can be reduced when you get to this point in the problem, then reduce it. But nothing goes into 3 that also goes into 7, so we're going to leave it alone. Okay. On this one, you got 5 minus u equals 0. The easiest way to do this is just move the u over by adding it to the other side, because it'll automatically be solved, because it cancels here, and that will give you 5 equals u, which is the same thing as u equals 5, right? So that's your solution. Okay. On these problems down here, we've got some added variation here. If you've got a number sitting outside here and you're set it equal to 0, so long as it doesn't have a variable. Notice this has a variable. This last example has a w in it, so we have to take that one and solve it. But here it's just a negative 5, so we don't need to solve a negative 5. We just basically ignore it because it's out front and it doesn't have a variable in it. So I'll ignore it, And I'll just look at the y minus 9 equals 0, and then the negative y minus 2 equals 0. Okay, so on this one, we're going to add the 9 to both sides. And on this one, I'll do what I did in a previous problem. I'm just going to move this y over to the other side, and it'll become positive. So I'll add it to both sides. It'll cancel there. So we get y equals 9. And when we move this over, we get negative 2 equals y, which is the same thing as y equals negative 2. Okay? Let's see, we've got 4 minus y equals 0, and we've got 4y minus 1 equals 0. Okay, so on this one, I'm going to just move the y to the other side by adding it to both sides. So that'll be 4 equals y, which is the same thing as y equals 4. And on here, it's going to be a two-step. So first, I will add the 1. And that will give me 4y equals 1. And then I'll divide the 4. And that will cancel, giving me y is equal to 1 over 4. Okay, last problem in the video. Okay, so this is different than what we were facing over here because this 3w has a variable in it, which means that we have to solve it. We have to use it as one of our solutions. So we're going to have 3w equals 0, w plus 4 equals 0, and then w minus 7 equals 0. So that's going to give us three solutions to this problem because this had a variable in it right here. Okay, so the only thing we need to do for the first one is get rid of the 3. So divide by 3, and 0 divided by 3, well, it's still 0, right? So that one doesn't change. Okay. Here we'll subtract 4, and over here we'll add 7, just doing the opposite. So we get w equals negative 4, and then w equals 7. And that is it.